Hello everyone, welcome back to my tutorial. In this tutorial, we'll solve a plate with hole model, 3D model with half symmetry. So this is our geometry. This is a geometry we are going to model it. So in the last case, we have modeled a 3D complete model. In this model, we will be simplifying the model into symmetry. We'll be using a symmetry boundary condition here. And this is the mesh we are going to generate. This is a linear tetra element we'll be using. So this is the displacement x, and this is a stress in x direction, and this is a one viscous stress. The symmetry model, which will reduce the size of our model, and it will reduce the computational time and modeling time, but it will give the same result. So let's get started. Now just open the Salome FEA. So Salome FEA is the wonderful open source free and post processing software, and it has the code aster, which will be very capable of solving finite element analysis. So please subscribe my channel for more videos and click the bell button for continuous notification. Now we'll go to the problem. So this is our problem. This is the actual problem. In this case, what we are going to do, we will be simplifying the model by taking the one off. So first, model the full 3D. This is 0.2, 0.1, 0.01. 0.2, this is 0.1, 0.01. Then we just want to create a cylinder here. For that, we just want to create a one point. This is in 0.1, this is in 0.05. just check the node is that point is creating. Yes, you can check here. There is a one vertices is generating here. Apply and close. Now we just want to generate a cylinder here. For that, just go to new entity, primitives, cylinder. Here there is a two option in cylinder. One is directly specifying the radius and height. The another option is called this one. This will ask base point, vector, radius, height, everything. So if you want to make some half cylinder or 3x4 cylinder or quarter cylinder, we can specify the angle here. But here we just want to full cylinder. For that, we need to touch this one. So first, this one is point vertices it has chosen. This is YZ. The radius is 0.025 and height is 0.01. Now save OK. So now we have generated a cylinder also. Now we just want to cut the material here from the plate using operation boolean, go to cut. So here main object is box, tool object is cylinder. Now just apply and close. Now you can see the cylindrical object is removed from the plate. Now what we want to do, we just want to cut one off only. For that, just create a plane, basic plane. So there is a point here, this one. Vector is normal to x, and the plane size is make it 1. Just apply and close. Now go to operation, partition. Here object is cut one, and tool object is plane. Then apply and close. Now you can see we have created a partition here. Now just right click this partition one, go to explode, choose here as solid and apply and close. Now you can see there is a 2 solid. Now we can take this solid 2. So now select the solid 2 and create the boundary condition. This is our final geometry. Now you can save this model, save, Vengat, pictures, code aster. This case is 7th case, this is off symmetry case. I just save it. Now just right click this one, create group. So this surface and this surface, just select these two surface by pressing a shift, then add it. This one is fix underscore x. This direction normal to the surface I just want to fix. Then apply. Then for 3D model we just want to constrain 3 directions. One is x direction, y direction and z direction. So here we have fixed normal to this x. One direction we have fixed. Then we'll be fixing y and z of this particular edge. So for that go to line, edge, add. This one you make it fix y and z. So then apply it. Now again go to this one. Now we just want to create force boundary condition. So this surface we just want to choose, select the surface, add. Here we can name it load. Then apply and close. Now we have created the boundary conditions. We have created the groups for applying the boundary condition. So now go to meshing. So select the solid 2, mesh, create mesh. Here use NetGen 1D, 2D, 3D and go to gear, 3D parameter. Here you just choose 002. Just make it OK and apply and close. Then right click it, compute it. Just wait for a while, it will generate the mesh. Now we have generated a little fine mesh, so it may take more time to converge. So just make it some little coarse. OK, apply and close, right click, compute. So this is the size we have given previously, the same size we have given. So this is a tetra element we have generated. Now just check the groups are taken into the mesh. Yes, the boundary condition groups are came here. Now just save this file and export this mesh. Right click, export MED file format and save it here. Now we have done geometry modeling and meshing. Now we just want to generate the command file for solving in code aster. So now we check with the boundary condition. So our force is 1000 Newton, then Young's modulus is 210 gigapascal and Poisson ratio is 0.3. Okay. So now go to here, there is a software called Efficient. So just right click this Efficient and open with other applications. Now use with open JDK Java 8 runtime and select. So this will get open. Now mesh type we need not to change, keep it the same. Now go to analysis type. This is a 3D model. Go to material. This is a carbon steel. We are using a SI unit 210 e power 9. This is make it as 7860. Assign to all. Make it add. Now element type we need not to specify any element type because we are not using beam element or shell element. Directly jump into boundary conditions. Now face imposed. Now we are fixing the face of x. So this fix x we just want to apply at face impo. So here name fixed x, assign to fix underscore x, x only 0, remaining you just keep it empty, then add. Now the another boundary condition is we just want to fix y and z in this particular edge. For that, go here, mesh group, DDL on mesh group, boundary condition name is fix, you can name it y and z, assign to same fix underscore y and z. Now make it fix of y and z. Remaining thing is keep it empty, so and add. Now we just go to loads. Here we just want to apply a force load to the face. Force face, this is, you can make it as force, this is just a load name assigned to the boundary condition group name is load. So this name has to be proper, otherwise it will show error. Now x direction we just want to pull it here, so the same, this boundary condition how it will apply is, it will apply as pressure only. So for that, whatever the value we are specifying, it will be a pressure. So 1000 Newton force means 1000 by area, you just put it 1000 divided by 0.001, add. Now just go to output, just we want to see stress and von Mises stresses and displacement, everything, just add all, then save it. Here pictures, code aster, static.com, save it. Okay, then exit it. Now you can check the command file now. So now we have generated the mesh, this is our mesh, this is our command file. So now you can see one by one. Debug means start the case, mesh, read the mesh, then definition of model, what type of analysis ours is 3D model with mechanic, then defining the material property, then assigning the material property to our mesh model, then defining the boundary conditions. You can see this fix x will fix the x direction, and this fix x, y and z is fixing the y and z. Then force, defining the force is FEA chair meca will define the force. Now result, this is the solver, meca static is the solver for static analysis. It will take model, material and this boundary conditions, then calculating the results. So calcsham will calculate all the results, and IMPR resu will save the results in decide format. So finally fin, it will close the solver. So now our command file is correct. Now just close the command file. Now go to Salome tools, plugins, use the run ASTK. Now just go to the location, just choose the location, here half symmetry, okay. First one is command file, next one is mesh file, then message file, result file, error file and output result file. So static dot com, this mesh is mesh underscore one dot med, this is, we can name it ourselves, message dot mess, result dot resu, error dot err, result dot rmed. So now we have set it everything. So this 20 means 20 is the input and 80 is the output. So now these are all output files. Okay, so now we can specify the memory of 2 GB and tick this interactive follow up and run the case. Before running the case, we just want to save it. So go to File, Save. So ASTK, we just simply name it and OK. Now we have saved it. Go to Run. If any error comes, it will quit. So first, after solving, check with the message file if any error comes. You can check diagnostic job is OK, that means there is no error. Now you can check the result file. So there is a result file, it is saved in RMD. We can open this file in Paravis and view the result. Now just go to Paravis. Paravis is the one of the wonderful post-processing tool for FEA in Linux. Go to here, Pictures, Code Aster, RMD, then OK. Then apply it. So now we have imported our model. Now we check the displacement first. Displacement dx. So this is the displacement. Now we can view this by using blue to red green. That will look good. Apply and close. Then here just go and change into 12. Okay. Now we just change that value. Background. To change the background into white, there are different background we can set, but I want the background of white. Make it white. Now just make it this one. Now we have seen the displacement x. Similarly, we can see the normal stresses. So here these are normal stresses, sigma xx. So I just keeping here. Now similarly we make it 12. This also looking good, but red blue the color will look good. So this is a normal stress. Here you can see the stress is 3 times higher than the applied stress. So 1 into 10 power 6 is the pressure we are applying here. Here we are getting 3.7 into 10 power 6, around more than 3 times. So now we can see the von Mises stress and equivalent stresses. So von Mises stresses, similarly you can change the value here. Rainbow, blue to red rainbow, apply and close. Here this value make it 12. Now this is the von Mises stress. So to see the displacement in deformed mode, just click this wrap by vector, then make it the scale factor into some 50, then OK it. So this is the way it will get deformed. And make the animation, right click, create new animation track, then click here. You can set some number of frames into 20, then click OK. Now here, now we can animate, just making loop and animate it. So this is the way it will get deformed. This is the off symmetry of plate with old model. So in next tutorial we will see quarter symmetry. We will take 1 by 4 the quarter model. We'll solve, we'll get the same result. We'll check the result with full model, half model and quarter model. Okay. So thank you for watching my videos. Please subscribe my channel for more videos and click the bell button for continuous notifications. Thank you.